Another compound pattern is Model View Presenter, or MVP. MVP really is a modernization on MVC that tries to enhance the testability of your systems. The way it does this is by really decreasing the amount of code that can be in the views and forcing the controllers, or presenters in MVP's case, to be more featureful. The model component in MVP is really the same as we saw before in MVC. It contains the data objects for our system. Now there is one small difference. While you can use the observer pattern within MVP the same as you do in MVC, it's often the case that the model will instead interact with the middle layer, the presenter in this case, using an event bus. An event bus is really just a third-party component that moderates the interactions between these two different layers. And that's just one thing to be aware of. It's not required, but you'll often see this in practice. Next, we have the presenter. So the presenter acts just as the controller did in MVC, but with a few minor differences. Now, one thing to really be careful of when you're designing your presenters is to make sure they don't have any dependencies on user interface components. And this is important because the presenter in the MVP pattern needs to be easy to test. And this is at the core of the pattern, right? And once you start depending on UI components, it becomes much slower and more troublesome to do this testing. Right? So you need to be really careful not to do that when you design the core of your presenters. The view is where the biggest differences in MVP lie. So one thing that we'll notice here is that the view isn't coupled to the model at all. What the presenter does is it acts as a mediator. It can go and update the model and retrieve state, but it responds to notify events, but it never ever passes model objects up to the view. Instead, the presenter only interacts with the view using primitive types. So it'll go and it'll send strings and numbers and arrays of strings and numbers up to the UI, and those will be rendered, but the view won't actually get model objects. Now this is great from a testing point of view, right? Because if you want to test your presenter, you know that the interactions from the bottom level are going to be these models that are really well defined, but you know that the way that it responds to any interaction is through primitive types, and primitive types are really easy to create assertions for. Also, by not passing model objects up into the view, it becomes much harder to have heavyweight views because they don't have objects to work with. They only have primitive strings and numbers and things, right? There's not a lot of data up there. So the view really has to pass data down to the presenter in a simplified format and allow the presenter to do all of the logic parts of the application. In this way, the views end up being really lightweight and the presenters are forced to take on a much heavier burden. And that's exactly what we want anyway, because the views are the things that are the most likely to change. And we want those changes to be easier to reason about. In fact, in practice, what you often end up doing with MVP is you'll write a lot of tests for your presenter and model, but you might validate your views only by inspection, just by looking at the code. Because it's a lot harder to screw up a method if it's just iterating over a list of strings than if it's iterating over some complex data type that's come up from the model. So just like we did with MVC, let's take a look at the interaction flow that happens within MVP. So the first thing that happens is the user performs some kind of action, and this gets passed down to the presenter. And again, like we said before, if this action includes data, only primitive versions of the data will be passed to the presenter. The presenter will then go and modify its internal state and update the model as it needs to. And that will be the second thing that happens. Once the model is updated, it will go and fire events that get passed back up to the presenter in this step 3 here. So one thing to keep in mind here that's a little bit different, especially when you're using an event bus, is the model often passes an instance of itself along with this notify event. So you can think of this as being the push version of the observer pattern, right? So the presenter doesn't need to go and then retrieve the data state from the model again. Now, once the presenter has this updated version of the model, the next thing it's going to do is go and update the view. This is the last step. Now again, it's really important that this update step is only sending primitives up to the view, right? So if you tried to log in, if your action was to do a login and you provided the wrong password, this wouldn't go and send some type of error object back up to the view. It would go and send a specific error message to the view. It might say set error with the error string, right? So it is really important that there's only primitives coming down and primitives going back up. And this really does, again, keep our views lightweight and easy to test, while also forcing our presenter to take on the burden of containing all of the business logic within our application. Just like with MVC, the main goal of MVP is to decouple the view from the model. But unlike MVC, MVP really does enforce this decoupling by not allowing any model objects to ever make it up to the view. Now this is great from a testing point of view, but it's bad in that it makes the presenters quite large. So it's often the case that we need to take a step back and think about how we can split up our presenters so that we don't just have one presenter object, which contains essentially all of the logic for our whole application. Also, the way that the MVP model uses the event bus changes the efficiency of the system. Right? So this is where we go and we step back and we're able to use the event bus to maybe make smarter decisions about how these notify events should happen. And this is one way that the complexity of the application can be simplified. In terms of the Mario example we talked about for MVC, the biggest difference comes from this decoupling between the model and the view. So what we need to do is we need to have the presenter interpret those Mario model and enemy model objects that get modified through the update notification path. And we need to make it so that the presenter then goes and sends primitive objects to the view, which specify how different Mario view figures are going to move around the screen. Right? So this difference is really enforced in this case. The model objects that we've created for our MVC pattern can't just be passed up to the view. The presenter is going to need to interpret them and pass up primitive representations of those objects instead.